This is lesson 5.4 with special parallelograms. What we're doing here is we're building on the idea of parallelograms with all those 6 properties that we've been working on, kind of memorizing and just making sure we know all those properties behind parallelograms and how to create a parallelogram, and understanding that if we have one of them that's true, then all the other 5 after that will always be true. Doesn't matter which one, but if we have one, then now we have a total of 6. This is a continuation of that and saying, okay, now if we know parallelograms, are there some special types of parallelograms that we could find? The first one we're going to talk about here is the idea of a rectangle. Okay, and so you're going to see that a rectangle is pretty similar to what we've talked about with parallelograms, the way that you've at least starts, can't even talk today. You'll notice that these first 6 pieces are identical to what we've been talking about with a parallelogram. So let me put those up on here on the screen so you can see them. Alright, so these 6 should already be in your chart, that chart that we're filling in for parallelograms. These 6 right here are already listed as properties of parallelograms. Both pairs of opposite sides are congruent, both pairs of opposite sides are parallel, both pairs of opposite angles are congruent, a diagonal forms 2 congruent triangles, diagonals bisect each other, and then one pair of sides is congruent and parallel. To go from a parallelogram to now a rectangle, we've got to be a little bit more specific. These 6 things right here are properties of a rectangle, and then we have 2 more pieces that make it no longer just a parallelogram, but now a rectangle. We're saying, okay, to make it a rectangle, because it's more specific, we need pieces that make it more specific. And one of those pieces is this right here, that the diagonals don't just bisect each other, and they don't just create 2 congruent triangles like number 4 and 5 here, but diagonals are also congruent to each other. They're identical in length. And then the second piece that makes a rectangle versus just a parallelogram is that all of the angles are right angles. Alright, so these are the 2 new pieces that you should have down for your diagram. Instead of writing all 8 of these pieces in your diagram for a rectangle, you notice there's not a lot of space. What I would encourage you to do to include all 6 of these is to say parallelogram plus. And what that says is all the properties from a parallelogram plus, and then write down only these 2 new ones for a rectangle. I'll show you a picture at the end of this video that'll kind of give a representation of what your chart should look like, and an easy way to kind of use shorthand to say, yeah, I know it's all 6 of these as well as these next 2 pieces. Alright, so that's a rectangle. Let's take a look here at the idea of the next piece, which is a rhombus. Some people call this a diamond, but the technical name for this, or the geometric name for this, is a rhombus. A rhombus is a type of parallelogram. It's going to have the same first 6 pieces to start. Let's see if I can get those to pop up here. Alright, so we have, again, all of these 6 pieces that are true for a parallelogram are also true for a rhombus. And we use the word rhombi for plural. Okay? So we have these 6 pieces, but in order to go from a parallelogram to a rhombus is a specific type of parallelogram. So we need to have more pieces that are unique to it. And so we have 3 new pieces that would be added in. One is that diagonals are perpendicular. Notice this doesn't say diagonals are congruent. That's only for a rectangle. Diagonals are perpendicular, meaning when they bisect each other, and when a diagonal forms 2 congruent triangles, when they intersect each other, they're now going to form a right angle. The next piece is that a diagonal bisects 2 angles, meaning it bisects the angles that are across from it. And I'm going to show you some examples in just a second that show you what that's saying. And the next piece here, step 9, or reason 9, is that all sides of a rhombus are congruent to each other. Okay, all sides are congruent. For a parallelogram, it says both pairs of opposite sides are congruent. It doesn't mean they're all the same as each other. It just means that if 9 and 9 are on the left and right, and 10 and 10 are on the top and bottom, then it's a parallelogram. With this, they all have to be 9, or they all have to be 10. Alright, so that's a rhombus. The very last piece we have here is the idea of a square. And you'll see on your chart that it kind of feeds in from a parallelogram and a rectangle and a rhombus is all that makes up the properties of a square. So you'll notice these first 6, if I can get these to pop up, are identical to what the first 6 properties of a parallelogram are. Then you'll notice that the next piece that pops up says diagonals are congruent. That comes from the idea of a rectangle. And diagonals are perpendicular comes from the idea of a rhombus. And then it says diagonals bisect 2 angles. That comes from a rhombus. All angles are right angles. That comes from a rectangle. And then all sides are congruent comes from a rhombus. What you'll notice here is the first 6 right here, 1 through 6, come from a parallelogram. 7 and let's see, where is it? Diagonals are congruent, and all angles are right angles. 7 and 10 come from a rectangle, and then 8, 9, and 11 come from a rhombus. You take all the properties of a rhombus, all the properties of a rectangle, all the properties of a parallelogram, and you put it together. Those are the 11 properties for what makes up a square. The way that this can best be shown and written is this picture right here. The first 6 pieces about a parallelogram are all written here. Again, order doesn't matter, and I should have the word both in front of all of these. Okay, both opposite sides, or both pairs of opposite sides are parallel, both pairs of opposite sides are congruent, both pairs of opposite angles are congruent. And then you'll notice, instead of a rectangle writing all those things out, we write just parallelogram plus, and then we have the 2 new pieces. Diagonals are congruent, and all angles are right angles. And then a rhombus says all the pieces from a parallelogram, so parallelograms plus, diagonals are perpendicular, a diagonal bisects 2 angles, and all sides are congruent. And then to make up a square, because it's all this 6 up here, the extra 2 pieces here and the extra 2 pieces here, for a total of 11, rather than writing them all out, it's the parallelogram plus, the rectangles plus, the new pieces for a rhombus. So we don't need to really write anything in here for a square, except to say we understand that it's 6, 2, and 3, a total of 11 pieces down here. Alright, so let's take a look at a couple of application problems for this. And let's close this one. Let's open this one. And let's see a couple of application problems for this. I should be able to draw on this. There we go. Alright. It says quadrilateral ABCD is a rhombus. Find the measure of each angle. Because this is a rhombus, the first thing you need to do is mark off that all these are the same and that diagonals are perpendicular to each other. Right? Those are the key things for a rhombus. You also need to understand or remember that the diagonals bisect opposite angles. So this and this are the same. This and this are the same. They're actually all the same as each other because opposite angles are equal and the diagonal bisected them, so it created equal pieces. Notice that this and this and this are all the same. So what we have is ACD, this angle down here, because this one's 62, the one right next to it should be 62. DEC is in the middle, it's a right angle, always. EDC is this one down here. If we can find out one of these two, we know both of these two. So 90 and 62, we can find out what's missing to say this is going to be 28, which means this is 28, 28, and 28. And then ABC, A to B to C, the whole angle is a total of 28 and 28 together, a total of 56. That's how to use the properties of a rhombus to be able to solve for the missing angles, the missing lengths of sides, things like that. Alright, look at number 2 here. Quadrilateral MNOP is a rectangle. Because it's a rectangle, don't we know these diagonals are identical in length? Right? MO is congruent to NP. Best way to go through this is to understand, okay, if this is 12, then this should be 12, and this is 12, and this is 12, because they're all congruent to each other. So what's the length of PL? That's easy, 12. Length of MO, the whole thing, 24. PON, okay, P to O to N is this whole angle. You need to remember that they're always right angles at the base. And then PMO, P to M to O, is this piece right up here. 29 has already been used, so we only have a certain number of degrees left over to make up 90. So if you think about it and you say 90 minus 29, you'll end up getting that that's 61 degrees. Alright, look at this next one here. I think that's actually everything that I want to cover with you. So those are some application problems that go along with the idea of a rhombus and a rectangle, and we'll do more of this practice in class when you come in on Wednesday. So have a great day.